Hello, this is question 10 from the 2010 exam. We need to find the dual problem of this LP problem, but we do not have to solve anything. So first of all, I'm going to write down the theory of the dual problem, just for a reminder to have on the side. So this is the theory. We have the primal problem, which is always a maximized problem in its standard form. And we want to find its dual, which will be a minimized problem in not quite a standard form, since the inequalities are greater than or equal to, but we can rewrite them in standard form anyways. So first of all, we need to make our problem into a maximized problem in its standard form. So we're going to rewrite that as maximize minus z, because when we turn a minimize into a maximized problem, we just multiply by minus 1. So we're going to have minus z is equal to minus 2x plus 7y, and that will be subject to, now we need less than or equal to inequalities. So since all of them are greater than or equal to, we just multiply all of them by minus 1. So that will give us minus x minus 2y is less than or equal to minus 10. Then we have minus 4x minus 5y less than or equal to minus 1. And minus 6x plus 8y is less than or equal to minus 4. And we always have that x and y need to be greater than or equal to 0. So in this case, our C, A, and B vectors / matrices will be, this is C, so C will be minus 2 and 7. We have A, which is equal to all the coefficients of x and y, so minus 1, minus 2, minus 4, minus 5, minus 6, and 8. And then also we have from here the vector b, which is minus 10, minus 1, and minus 4. And from these, we're going to use these to find our dual problem. So, writing down the dual will give us a minimized problem, first of all, and then we're going to have y, which is equal to b transposed, so this is b transposed will be minus 10u1 minus u2 and minus 4u3, and that will be subject to, we have A transpose U, so since A transpose will give us one constraint from here and one from here, we can write down minus U1 minus 4U2 minus 6U3, that's for the first inequality. And then for the second one we will use these, so it will be minus 2U1 minus 5u2 plus 8u3, and these will be greater than or equal to, since we have greater than or equal to over here. C transposed, where C was this one, so transpose will give us minus 2 here and 7 down here. And we always know that ui is greater than or equal to 0. So now this is the dual problem, but we need to write it down in its standard form and into a maximized problem, since in the beginning we had a minimize and the dual obviously needs to be a maximized problem. So making that a maximized problem in its standard form will give us maximize. We have, I'll name it W, but it's minus y actually, since we multiply by minus when we want to turn a minimize into a maximize problem. So that will give us 10u1 plus u2 plus 4u3, and it will be subject to, now to turn the inequalities into less than or equal to inequalities, so in standard form, we need to multiply both of them by minus 1 again. So we will have u1 plus 4u2 plus 6u3 less than or equal to 2, and the next one will be 2u1 plus 5u2 minus 8u3, and it will be less than or equal to minus 7, and again we have that ui is greater than or equal to 0. So now this is the dual of our primal original problem, and since we do not need to solve this problem any further, this is all we need to do. So nice and easy.